Hello, how are you? In today's video, we'll see how to create our own identity or our own set of formulas whenever we are seeing any trigonometric problems. Whenever we are seeing any trigonometric problems, we are always in hunt of trigonometric formulas. So which trigonometric formula I have to apply here? Which trigonometric identities I have to apply here? But nowadays, that times are gone. Now, JEE Advanced or any exams, they are always enforcing us to create our own identity at that particular time when we are seeing a problem. So let us see which problems today we are going to discuss. This particular problem is from JEE Advanced 2026. So let's see. So let alpha equals to 1 minus 2 cos pi by 11, 1 minus 2 cos 3 pi by 11, 1 minus 2 cos 9 pi by 11, 1 minus 2 cos 27 pi by 11, 1 minus 2 cos 81 pi by 11. Then the value of 5 minus alpha square is what? So as a student, when I first saw this particular problem, I was thinking, yeah, which particular identity I have to apply, or is this related to some formulas that is related to 1 minus 2 cos alpha like that. But when we see this particular problems in a very new way, then we will see that okay, we have 1 minus 2 cos alpha, we have 1 minus 2 cos 3 alpha, 1 minus 2 cos 9 alpha, 1 minus 2 cos 27 alpha. So there is one pattern here, that is 1, 3, 9, 27 and 81. Okay, then what we'll do with this particular pattern? Okay, then another thing is that all these terms are in multiplication form. All these terms are in multiplication form. If somehow we are able to replace these terms with some ratio terms like a upon b, then what will happen? Okay, then all these terms will comes into some simple like a1 by b1, a2 by b2, a3 by b3, like that. Okay, then what will happen? Have you heard about telescoping series? Yes. If somehow we are able to generate a telescoping series here, then that will be easy for us. So instead of going in hunt for formulas, let us first derive our own identity here. So which identity I want to generate here? Okay, see, in every patterns, in every multiplication terms, we have 1 minus 2 cos alpha like that. Okay, so let's see first 1 minus 2 cos alpha. 1 minus 2 cos alpha. What we can do here? So our main idea is to convert this particular terms in some ratio terms. Okay, then how we'll convert this into ratio terms? So now think, what are the formulas you know? If somehow we are able to generate this as like some trigonometric functions, same trigonometric functions minus same trigonometric functions, then we can apply like sin alpha minus sin beta, or cos alpha minus cos beta, like that. Okay, then how we can do that? Okay, since this is 2 cos alpha, if somehow we are able to create here 2 sin alpha into cos alpha, then that will converts into sin 2 alpha. Yes. Okay, so let us multiply it and divide it by sin alpha. So 1 minus 2 cos alpha, we have multiplied here sin alpha, and we are also dividing here by sin alpha. Okay, then it will become sin alpha minus 2 sin alpha into cos alpha upon sin alpha. Okay, then that we have discussed. So what we can write? We can write it as sin alpha minus sin 2 alpha upon sin alpha. Now we are able to generate sin alpha minus sin 2 alpha in numerator. So now we can apply sine A minus B or sine alpha minus beta formula here. Yes, so let us do that. So that will becomes 2 sine alpha minus 2 alpha upon 2 into cos alpha plus 2 alpha upon 2 upon sine alpha. Now this has become 2 sine minus alpha by 2. So I am writing a minus of 2 sine alpha by 2 into cos 3 alpha by 2 upon sine alpha. So can we further simplify it? Yes, we can simplify it, and we will get here 1 minus 2 sine alpha by 2 into cos 3 alpha by 2 upon, we want to write sine alpha is 2 sine alpha by 2 into cos alpha by 2. Oh, we are able to write this in the form of ratio, that is cos 3 alpha by 2 upon cos alpha by 2. Oh, now let us see our problem. So this is 1 minus 2 cos pi by 11. This is 1 minus 2 cos 3 pi by 11. This is 1 minus 2 cos 9 pi by 11. Now we can generate a telescoping series here. How? By after applying this particular formulas here. That is, in place of 1 minus 2 cos alpha, we can write minus cos 3 alpha by 2 upon cos alpha by 2. So for each terms, we have to write minus cos 3 alpha by 2. So what is our alpha? Alpha is nothing but pi by 11. So that will be 3 pi by 22. How? 3 alpha by 2. 1 minus 2 cos alpha equals minus of cos 3 alpha by 2 upon cos alpha by 2. So minus 3 cos alpha by 22 in numerator, and in denominator cos alpha by 2, that is pi by 22. So for each we will get minus, minus, minus. So since minus is multiplied here 5 times, so that will becomes minus only. So now onwards I am not going to write minus always. So 1 minus 2 cos 3 pi by 11, what we can write? We can write cos 3 times of this, that is 9 pi by 22 upon cos 3 pi upon 22. So what we are seeing here, that we are seeing here some telescoping pattern. So this pattern is in numerator and this pattern is in denominator. Now when we'll convert next terms, 1 minus cos 9 pi by 11, we'll get cos 27 pi by 11 upon cos 9 pi by 22. So why we are getting telescoping series here? Because 3 is there in our numerator terms. So 3 times of minus cos 3 times of alpha by 2 upon cos alpha by 2. And we have 3 like multiplication of 3 here also, that is 3, some 9, 27, or more precisely exponent of 3 here. So that's why we are getting telescoping series, and that's why this particular identity that we have created here is helping us in generating telescoping series. So what will be 1 minus cos 2 cos 27 pi by 11? So that will becomes cos 27 3 is 81 pi upon 22 upon cos 27 pi upon 22. And last we'll get cos 3 times of this one is 243 pi upon 22 upon cos of how much alpha by 2, that will becomes 81 pi upon 22. Now see, we have a telescoping series in multiplication. That means this particular terms will cancel out with this, particular terms will cancel out with this. That means numerator of previous terms is cancelling the denominator of next term. So all these terms will be cancelled out and we left with 2 terms only. So our this complicated looking problems becomes simple one, and that becomes cos 243 pi upon 22 upon cos pi by 22. Now they have given us problems to solve now, so that means this must be converted into some simple terms. So how? See that this particular terms is 243. when you will divide this by 22, you will get minus of cos when you divide it 1, and after that 2, 3, 1, 11 pi plus pi by 22. This you will get here. Okay, so cos pi by 22. So 11 pi means odd pi plus theta, that will comes in third quadrants, and their cos is negative, so that will becomes minus minus plus cos of pi by 22 upon cos of pi by 22. Oh, this alpha is nothing but equals to 1. So this our alpha that is equals to this complete terms or this complete quotients, that is nothing but 1. Oh, we got our alpha. That means they have asked 5 minus alpha square. So 5 minus alpha square is nothing but 4. So what is the what we have did in this particular video? So we have not applied here any fancy problems. We have just generated a particular formulas or identity that this particular problems demands. So don't always rush whenever you are seeing any trigonometric problems. Don't always goes in hunt for trigonometric identities or formulas, because in trigonometry now we have a lots of formulas. That's why always we are not applying our full brain there. So we are relying on all those formulas. So subscribes my channels for such type of videos. All the best. Bye bye.